what we decided to embark upon. And so in 2017 then, remember I said I flew into Walmart. We basically they said, look, challenged us to say, okay, fine, prove it to me that you can do something with this information sharing. So what we did is a pilot, the mango pilot. Actually, we did 2 pilots, one with mangoes from Mexico coming to the United States, another with pork in China. And what we proved was the following. So we did a piece of work, and at the end of which, the head of food safety at Walmart then, who now is the deputy director at the FDA, Frank Yanis, he walked into a Walmart store and he told an employee, here is this package of sliced mangoes. Go tell me where it came from. It took the employee roughly about a week to do this, and Walmart prides itself on being able to do it faster than pretty much anybody else. So that's basically sort of a best case scenario. Yeah? And no surprises for technologists. Basically, what we did was all the 12 plus steps in the supply chain, the players, were sharing information on this IBM Food Trust blockchain solution. And the whole thing, we could trace in 2 seconds. Now, this is a big deal. Why is it a big deal? If you go back to that spinach problem that I talked about, right? It took months and still they didn't have a good idea of what happened. Here, within seconds, you can, if you can identify a batch of contaminated whatever, you should be able to trace it back to the source. And we can, right? That's one. So if the problem with the packaged mangoes, you can trace it back. And also, similarly, you can trace it forward to where all it went, right? Because you're collecting that information. So this convinced us 2 years ago that we are on the right path to go build something. And that's what we did. It's a busy chart, but I'll tell you essentially what this is all about. So what we've built is what we call IBM Food Trust, or the Food Trust platform. Really what it is a platform in the sense of it's an information sharing platform. If you think about the layers, look at the picture, right? It starts with the blockchain itself. There's one layer, which basically is a set of copies of a database, if you will, right? That's run by a set of companies which we call trust anchors. All it is the selected set of parties that are managing the integrity of the database on behalf of the entire community. So you have that. On top of the blockchain, much of what Food Trust does is it brings the Walmarts, the Krogers, the Nestle's, various companies onto the system. So the ecosystem is a big value proposition. They're all on the system, right? The third is raw data comes into the system from various parties. You have to do the work to link things together to be able to trace, right? I'm just giving you the core essential idea, but there's a whole lot more to it. So essentially all the work that is required to make this a true shareable platform, managing members, knowing the provenance of things, all of that is basically a layer which basically I would call the Food Trust platform. That is information in there. And then the layer above is we've built 3 applications on top, and we want others to build applications on top. So it's truly an information sharing platform, a couple of applications built by IBM, and the rest built by others. So far, the way I stated it, where is blockchain and smart contracts? I'll just close that last piece too. Now, much of, a significant fraction of the information in the Food Trust platform will be accessed via interface APIs, and people will build applications. That's a norm. But there is going to be cases where, let's say, a fresh beef manufacturing facility is sending stuff to, let's say, a restaurant chain. They want to be proving to each other that they manage the fresh beef appropriately from a temperature perspective, right? When you want to do things like that, essentially what we do is that specific data that's relevant, think of it as we copy it over to specific individual nodes for those 2 companies, and they can run smart contracts if needed. So essentially there are 2 modes in which this platform can be used. One is straightforward, regular run-of-the-mill applications you build on top of the APIs, and the other is companies can run smart contracts to solve various challenges. The biggest, and I'll go through a couple of examples in applications in detail, but this is the vision and this is what we're building, right? An information sharing platform, leveraging blockchain technology, building a few apps ourselves, and allowing others to build applications on top. Now, how does the data come into the system, right? And that's what you see at the very top, the onboarding and ingest box there. this is a crucial piece, right? Remember, all these companies are sending data about strawberries or spinach or what have you to the system. And when we started, we wanted to make it as simple as possible, right? So sometimes you might be dealing with a small farmer who doesn't have much in terms of IT resources. Sometimes you're dealing with a big company like a Walmart, right? Which is there's no problem. Also, the type of information, the amount of information they may have varies. So we had to be very accommodative. The other thing is, one of the key things we wanted to make sure of is we did not want to specify the supply chain process itself, right? So you don't want to say, look, if I'm at Driscoll's, I get these strawberries from the farm, I do X, Y, and Z, and make it a very detailed description of the supply chain process. And then it's sent to us. We don't want to have any knowledge of the supply chain process. We want to infer it from the data as the approach we took. The reason being, supply chains are dynamic. Today I'm buying from this company, tomorrow I'll buy from somebody else. And it can be done on a dime, especially retailers, many retailers, they quickly change where they buy this produce from, for example, right? So these are some of the things that we thought through as we built the solution. And this is essentially the heart of what we are trying to build. So I think I'll start there. Now, I mentioned it's an information sharing platform and data comes in. So first question is, how do you approach this thing? What type of data comes into the system? I would say there are 4 categories, and really 3 plus 1. The first is transactions. So I'm a Walmart. I purchase something, so I send a purchase order. I want this many pallets of strawberries. Driscoll says, yep, I shipped those 2 pallets you asked for. And Walmart says, yes, I received. These are what we would call transactions. So companies send us basic transactions. The second thing they send us is master data. What do I mean by that? Right? We need to know exactly what products are in the system. So products and facilities. So if Walmart is in the system and they're dealing with, let's say, strawberries, they got to tell us exactly all the distribution centers and the stores where the stuff is coming, right? So we have master data. And then the third piece is the most important piece. Everybody has to tell us what they did with the stuff they got from upstream. So for example, I got cream and sugar and vanilla, I made ice cream, and I shipped it downstream, right? So what did you receive, what did you do, and what did you send on? These are what are called EPSIS events. It's basically a standard. Fortunately for us, when we started on this journey, there is a standard called GS1, and so we decided to leverage it. I don't want to go into the details, but it's being adopted in every supply chain, right? Pretty much. In healthcare industry, it's being used in many other industries. So we picked one, and there was a reason also why we picked, by the way, GS1, and that is, if you think about the previous chart that I had, right? We built it primarily for the food ecosystem, but if you think of the layers, there was the blockchain layer, there was the ecosystem layer, there was all the provenance and various capabilities we added to the system. That can be used in aircraft supply chain also. So we built something for food, but much of what we built can be used in multiple ecosystems. And so we really are looking to partner with companies who will take what we built and build something for aircraft parts provenance, or in the drug industry, for example, there's the Drug Serialization Act, which basically requires companies to have track and trace capabilities for drugs at the unit of sale level. You can leverage this technology for doing that. Anyway, I'm losing track of where I'm going in the story. Let's back on track. So essentially here, these are the types of data. And the last 3 plus 1 I mentioned, the last is data payloads. So remember I gave the temperature example? There is metadata you may want to attach to goods as they go through the supply chain. So we wanted to have an extensibility, and so we basically have what is called a data payload capability to attach any type of data, opaque, that you can add to the system. So this is what companies have to do. So which means when I say a company like Walmart is onboarded onto our system, what it means is they're connected to the system, they've picked a set of products, and they've decided to share all their data, the locations where the goods are flowing through, and they send us these types of event data to us, right? On a continual basis, programmatically, right? Okay. So when we designed, I think I already mentioned this, top level, essentially, we wanted to make sure that we make it as super simple as possible, right? And we wanted to allow people to send data regardless of what they have in some sense, right? So we were generous with respect to, and being forgiving, if you will, not generous. Forgiving is the more appropriate word. In terms of what data they send to us, we infer everything in the system. right? So the key thing is what it says at the bottom. We make sense of all the data that comes in, and the folks who send it, send it whatever they have. And in fact, if you think about, again, strawberry supply chain farmer to Driscoll's to Walmart, in that example, the data from Walmart may come first. It really doesn't matter to us, right? We take the data, and based on information in the data, we try to link things together. And that's basically what we do in the system. And the same thing, so that's why it's very generic and can be applied in any supply chain scenario, right? And so I'll just walk you quickly through two specific, and in fact, I'll probably speed up a little bit. So the first application we have built is Trace. And as you can imagine, it's fairly straightforward. Essentially, what this shows you basically is, pizza basically being, frozen pizza coming out of ingredients from 9 different farms, went to 2 warehouses, and eventually came to a manufacturing plant where the frozen pizza was made, and then it was shipped through 5 distributors to 125 stores. It could be Walmart stores, whatever, or when I say store, I mean grocery stores, right? This is the level of detail that you get. All of that is based on this raw data, little pieces of information we get from all the parties, right? So the raw data is on the blockchain, so we can provably show that everything is accurate, but much of our value is in the business logic of creating this thing on top in the system. In fact, I would say 80% of the code is above the blockchain layer, and 20% of the blockchain layer. And blockchain is really, for me, a trust layer. Beyond it, we do much of the work above, right? And it's very complex to do this, especially since we are being super forgiving in terms of the data coming in. Okay, so that's what Trace does. And so the impact of Trace is clear, right? You can do surgical recalls. You don't have to basically wipe out all the spinach from the shelves, right? So that's basically, and also this can be used for, if it's organic food and you keep track of where it started, you can reduce food fraud too, for example. And on the left-hand side, it shows you this is a serious problem. Okay, now, and like I said, the talk is not going to be too technical, but at a high level, this is the crux of it, right? From a technology point of view for this application. How do you go from unstructured data that comes in bits and pieces, which have all the problems at the bottom, missing data, duplicate data, ambiguous data, many-to-many sort of relationships. So for example, one batch of strawberries could be put into many cases, or many batches could go into one case. All these various permutations and combinations, we got to seamlessly be able to handle, right? That's a key thing. The other is we truly don't know what that supply chain is, meaning who are all the parties through which this particular item goes. And so essentially what we have to do is dynamically infer this. And so everything is done dynamically based on data that's in the blockchain, right? Which is also quite challenging, and especially given the fact that in early days of blockchain, the technology is only so performant. We had to do a lot on top, right? In fact, we had to have a cache, if you will. Without it, we couldn't give you a response time that is immediate. So many things had to go in to make this happen. So that's Trace for you. Fresh insights. Another application we built was just based on these snippets of data on, I received this, I did this, and I shipped it downstream, we're also able to aggregate it across many examples. Why would you do that? You can solve problems like freshness and food waste, for example. So what we do here basically is we give you real-time insights into, in every facility, how many batches of strawberries are there, and what is their dwell time? How long did it stay at the facility? The longer the dwell time, meaning you're not pushing the product through to the end consumer. You got to do it as quickly as possible, I mentioned earlier, right? Because fresh food deteriorates as kept in one spot. Then, so this is the sort of information we are able to gather and provide. All of this, again, based on, so that's another part of what we do in Food Trust is we give you aggregate information and insights into what's going on with the supply chain. The same thing can be useful for many products, right? Which inventory is something we show, which is also very useful and powerful. And in fact, we can show inventory across companies. So you can think of doing things like continuous replenishment, where I know basically how much of, I'm Driscoll's, I know exactly how much stuff is at the Walmart stores, at various stores, and then I can basically do things. Of course, all of this assumes that the companies have decided to share that information, because whatever they've decided to share in terms of permissioning rights, we enforce that in the platform. That's where the blockchain layer comes into, right? So that's basically what this. So this gives you a sense of a couple of applications that we have built. And and you can do interesting things, right? Like you can do aggregate level view of things. So for example, if I'm, again, Driscoll's use that example. I want to know across all my facilities, which are the facilities that are doing well with respect to dwell time. You can do that, and we give you views for that too. So very powerful set of things, all coming from very simple raw information that's shared in the system. This just talks about, mainly I put it up there for similar challenges, right? Missing data, mislabeled data, out of order events coming from organizations. We have an inventory API, but imagine, right? So farmer to Driscoll to Walmart. Walmart sent us some data. The others haven't yet, because they can send it any to which time that they want, right? It's not that it has to be sequential. So if you ask for inventory, what do we show you? We can only show you what we know, right? So there are things like that. So you have also this notion of how do you interpret the inventory you get out of the system. After a few days, yes, it will all be fine. You'll see the perfect inventory and all that. But instantaneous inventory, there are these tricky things where for certain items which are in flight, is the inventory reliable? So there's plenty of research problems here too. But these are early days from my perspective. But I think at least we have a reasonable approach. And this is very unique because I've not seen any solution built on a supply chain that does these sorts of things. So we're very happy with what we've done so far. And there's plenty of interest in this too. Okay, I'll quickly run by this chart. The only point I want to make is technology is the least complex stuff that we deal with in this whole exercise. Much of what we do is making sure everybody, the farmer has to feel comfortable. I'm going to upload information, right? Is going to be, what am I getting out of it? I'm doing the hard work of uploading spreadsheets. By the way, we allow that too. Spreadsheets for the data I talked about. And what do I get in return? Do I see some data from Walmart? So there's those questions you got to answer. The ecosystem has to see the benefit. The governance. This is crucial. Who owns the data? In IBM Food Trust, IBM owns none of the data. It's owned by the company who uploads it. Very different from the model that most companies use, right? Consciously so. Then who can see the data? All of that is important. Standards for interoperability and technology, like I said, is the last piece of the puzzle. Okay, so where are we in this journey? So just to give you a sense of how far we have come. Today, basically, IBM Food Trust is in production. It's been since October last year. And truly, this is the largest scale information sharing platform in the supply chain that I'm aware of that also leverages blockchain. And the kind of things we have in the system, so it's like in September last year, Walmart, thankfully, for us, decided to ask all its leafy green suppliers to be on IBM Food Trust. So by September this year, if you're supplying to Walmart, you're on the system. So if something happens, and at least from a Walmart perspective, they should be able to trace back and do a better job of recalls, right? Very powerful. Different companies also, remember I said business value, different companies also approach it with different goals in mind. Carrefour is a retailer out of Europe, and actually they're in 30 odd countries. Their focus was something different, and I'll touch upon it, but they're on IBM Food Trust. Just recently, Albertsons signed up on IBM Food Trust, right? Albertsons, Safeway, yeah? Nestle and Carrefour just recently demonstrated how they, for a specific brand of sweet potatoes, muesli brand as they call it, farm to store traceability on the system. So it's exciting. There are about 80 plus clients on the system, number of transactions growing. So we are super excited about where we are in this journey, but there's a long way to go. Think about the number of products we eat, number of retailers, number of suppliers. It's a long journey, so we are in it for the long haul, but we are at a good spot in our view, right? And like I said, the technologies that we have developed so far can be used in other supply chains, so that's another angle that we're pushing. Okay, so what problem was Carrefour trying to solve? So what they wanted to solve was, for a specific category of products, they wanted to show to the end consumer, right? That it came from a certain source, et cetera, et cetera. So in other words, they were looking for a marketing opportunity to see if sales can go up. And so what they did was, in fact, today if you basically walk into a store in Spain and buy a specific brand of chicken, there's a QR code on it. When you scan it, it tells you everything about the history of the chicken and stuff, right, from in the system. And it's all coming out of IBM Food Trust, the trace that we talked about. We have APIs for some of the things I mentioned, right? That's how it's done. So let me just show you a short video clip of what that actually is, right? This is deployed in the system. What happened?
En Carrefour, trabajamos de forma permanente para satisfacer las necesidades de nuestros clientes. Por ello, contamos con nuestro pollo campero calidad y origen, criado sin tratamientos antibióticos. A partir de ahora, mediante la tecnología blockchain, puedes obtener toda su información. Carrefour es la primera empresa de distribución en España en implantar esta nueva tecnología, la cual garantiza a nuestros clientes una total transparencia en la trazabilidad de nuestros productos. Solo necesitas un lector de códigos QR. A través del código impreso en la etiqueta del envase, obtendrás toda la información asociada a la trazabilidad del producto, desde la fecha y lugar de nacimiento, al tiempo exacto de cría y su alimentación, hasta la fecha de envío a nuestros almacenes de Carrefour. El ejemplo del pollo campero es solamente el primero. Nunca había sido tan fácil comprar de manera tan segura.
All right, so fairly straightforward, right? Even though it's in Spanish, that's basically an example of a product that's on our system. All right, another example, just to give you another concrete example of something that we have run a pilot on in our system. Golden State Foods is a key supplier of beef patties and many other products to the food services restaurant industry, right? A fairly big player, but since we don't keep track of those who supply to food services companies, maybe you've not heard of this name, but fairly big and an important player. What they wanted to do was ensure that if you think about fresh beef, just like strawberries, fresh beef lasts for about 14 days. Frozen beef for about 60-70 days. So when you move from fresh beef to frozen beef, or let's say if you're in the restaurant industry and for hamburgers, for example, the patties, that's a significant change in the way you handle the inventory. So what they wanted to do was keep track of fresh beef inventory and ensure that basically you manage the freshness. If something is spoiling a little bit, you rush it through the supply chain, right? Or if you basically are in the restaurant itself, from the cooler, when you take stuff out that's going to spoil first rather than what came in first. So, right? Things like that. That's what they want to do. And that requires to, again, onboard onto our system, both the Golden State Foods and the restaurant chain that they were working with, get onto the system. And here, interestingly, remember I said the 3+1, the fourth type of data, metadata about temperature. We used RFID also, and I'll show a short video clip of how this works. So that's the problem they were trying to solve, and very successful pilot, by the way. And we're convinced that basically, supply chains will be transformed with something like this, especially the food supply chain. I can imagine the same thing may apply to vaccines too, right? In the medical supply chains too. So I'll just play another video clip just to give you a sense of how that system works.
Nothing beats the taste of a fresh, juicy hamburger. But what does fresh really mean? And how can customers be confident that the burgers they're eating are truly fresh? It all begins here, where the patties are made, boxed, shipped, and distributed along a long, complex supply chain. Today, Golden State Foods is showing how to ensure its patties' freshness and how the process can serve as a model for transforming the entire food system.
Golden State Foods is a provider of goods and services to various quick service restaurants. We have a manufacturing facility in Opelika, Alabama, and we produce over 160 million pounds of beef products every year.
This is how Golden State Foods and IBM are using blockchain, radio frequency identification, and the Internet of Things to make customers more confident in the food they eat. This is the extra mile.
Personally, fresh is right off the hot grill. You call it fresh. It hasn't been held for too long. You call that fresh. GSF has always been known for high quality innovation and customer service. For us to be able to show that freshness along the supply chain journey has been the mission.
Beef cattle industry is very segmented.
You have three different parties in here. You have the supplier, you have us, and the restaurant. So that's three different systems, and each system comes with a host of issues. So there's ambiguity in front of me and behind me because I don't have access to their systems. I have to make a phone call, send an email. I have to have an action that grabs data from them.
The lack of transparency is not because anything's being shielded, it's just because of the segmentation.
With a blockchain solution, there's no action. It's already there. I just log in and look.
The ability to stream data along the food journey is that aha moment for us. We have to focus on going after the right partner in this journey, and IBM became a natural choice for us.
We apply a RFID tag to each box as it comes through. Then through the production process, we produce the patties, package them, and put the package into the box that contains the RFID tag. Once we accumulate 98 boxes, we form a full pallet. That pallet is then sent through a stretch wrapper. At that time, the RFID sensors are read and they're associated to that particular pallet ID. When we put the product into storage, as it comes out of the cooler, we read that pallet as well. So that's our second checkpoint at the facility. Finally, once it's shipped to the distribution center, once it's loaded onto that truck, we have another RFID sensor that will pick up that transaction there. It really lets us be more proactive.
I think that's good. So you get a good sense of how this system works, right? So just to quickly summarize, in terms of the storyline so far, what I just want to summarize overall. So really, blockchain, for us is a trusted, decentralized information sharing platform. There are permissioned and permissionless variants. Most businesses tend to use the permission variant. There are many options for the technologies. We primarily use something called the Hyperledger Fabric that we are behind. And then we have been building solutions on top. And building a solution is a lot more than just the raw technology. That's the easiest, simplest element. The harder job is to convene and to motivate an ecosystem of players to start sharing information, right? Governance and data governance and all the good stuff. And we have done that for a couple of areas, couple of solutions. One is Food Trust, another is something called TradeLens for the ocean shipping industry. So there's a second solution that I'm responsible for. That is another example of this thing. And all of these solutions, the way I see them evolving is companies like us will build these solutions for an entire ecosystem of players, for the food ecosystem, for the ocean shipping ecosystem, for the banking ecosystem, etc. A lot of work will be spent building the platform. There'll be a few sample applications that these companies themselves will offer, but much of it will be, just to use the Apple analogy, right? You have the basic platform. You'll have a few apps from Apple. Rest are coming from others, right? That same model is what I expect to see. So hopefully this gives you a good sense of what some companies like ours, like IBM, and what I've been doing over the last 3.5 years, doing with blockchain. It's yes, it is all based on the technology, but a lot of the hard work is actually in trying to build these things. And hopefully this gives you a good sense of how we are trying to do it. And I'm super excited because this is real, right? We have the top 4 retailers in the US running on our system, right? 3 years ago, if you'd asked me this, I would say, really? It's going to happen? But it has happened. So, thank you.
But during his talk, I did look up what Gartner said about blockchain in a report in October last year. Of course, first of all, it's over the overhype, it's heading into the trough of dissolution. And there's however, they did say blockchain, quantum computing, and AI will be 3 technologies that will drive disruption and drive new business models in 2019. So I think that with that, open for questions.
Yes.
Okay. So can you talk a little bit more about cost and data? Is this data already being collected, or was it new work for all these suppliers in Walmart?
It varies. It varies. So in order to send the data to our system, first of all, the data must be available somewhere. Secondly, it must be easy for them to send it to us, right? So I'll give you the example of at least one retailer, so I don't name names. What they did was they had in the store, a scanning of produce when it comes in for a certain purpose, right? Quality assurance. They decided to use the same process when they scan. This time they're scanning a label that sends us information. So a lot of companies basically use existing processes and just right on top of existing process to send us data. They are the successful ones. There are others who really require some extra work to make these things happen. Their things take a little longer from an onboarding perspective. But yeah, I think most of these companies are able to do it. Some very quickly, some not so quickly. But it really depends on their internal IT state, if you will, right? The IT landscape state.
Question over here.
So I appreciate the complexity and the value of these inputs, the transaction model, the data model, but it's not quite clear to me why Hyperledger blockchain is a better fit for the data storage layer than, say, D2.
So the key thing to keep in mind is, suppose, let's say there is a temperature-related dispute, just to use that example. How are you going to be able to resolve the dispute automatically? This is where blockchain comes in. If all you're talking about is sharing of information between these companies and you're surfacing it to through an API, there is, you could argue, not necessarily a need for a blockchain, right? So really think about it this way, right? We have to create this information sharing layer that allows you to do smart contracts, but at the same time realize most companies are going to leverage the data shared with them to do their own things, combining it with the internal data. Right? So you want to do both. That's why blockchain comes in. And whether it's Hyperledger Fabric or something else is totally irrelevant and conceptual to the application. But of course, given the fact that we have spent so much on hardening the Fabric technology ourselves, we are using it here. That's it. So it's really about, there are real disputes that are involved in supply chains, in the food supply chain, like I mentioned, right, or in organic food and all that. That's the reason. In terms of our journey, we're doing a lot more on the API-based stuff because it's easier to get started there. This is where we are in our journey. It's really a point-in-time statement, but by the end of this month, early next month, we'll start allowing companies to run their own nodes. Once that happens, it's really all about smart contracts. And then, absolutely, you need blockchain for that.
Question over here.
Yeah. So 2 questions. One, are there any token economics around this model right now, or how does IBM monetize this? And second question is, blockchain maximalists, like their earlier question, this is another database, and if you got the wrong information and the garbage in, garbage comes out the other end, somebody is just inputting the wrong. I saw that second example with when you can get a digital originator, like an Internet of Thing type of input, like that read, the control, that seems to have less of a garbage in problem. But how are you addressing this issue? Are you optimistic that you can get, I can see the usefulness of having the speed to identify what they call, like I'm saying, but if you input the wrong information about the spinach, out of the spreadsheet, as you seem to suggest you can get, how do you deal with that? How do you envision this evolving?
So great question. So I'll just address the second part, then you may have to remind me the first part. The second thing was all to do with the garbage in, garbage out problem, right? And I'll expand it beyond that, right? The fact that the data that comes in is either bad or it's because of mistakes or whatever, or because of malicious intent, right? So either can happen. The blockchain basically, once it gets into the system, just keeps it in an immutable ledger, right? So therefore, you have to do something about securing the edge. And the approach we take is basically one of suggesting, like you rightly sort of inferred, as much as possible data comes in from IT systems, right? IoT devices and so on and so forth, so that there is no human in the loop. Human beings are the hardest problem when it comes to fraud and everything else, and mistakes too. So you try to get things out of internal systems as much as possible. Temperature, it has come straight from the sensor, and so on and so forth. So there's a set of principles we use to ensure that you secure the edge as much as possible. And we have a whole bunch of research activities going on in terms of ideas to make that happen. Fancy names like crypto anchors and so on and so forth. You can look it up on the web. So that's an important area of study, research, right, to ensure that the core value of blockchain expands all the way to the edge. The first question had to do with token economics, right? So for this to work, permission blockchains in general, Most of the apps that companies buy, like a Trace, to them it's like a software as a service application, right? So they're really paying for the service. And when they pay for the service, it pays for the infrastructure as part of paying for the service. There is in principle no need for token economics. But that being said, I also mentioned that in permission blockchains, maybe there will be value for tokens, right? And I can see some examples. Imagine basically, and we are working on projects like this too, on top of Food Trust. A consumer buys something, let's say coffee or whatever else, and when they buy it, they want to make sure that they want to pay the farmer something. You can enable that with tokens in the system, but you could also enable that by just keeping track of how many times you decide to purchase and pay something, and say, okay, there's 50 times, 5 cents. You can basically pay by regular money too. So token economics necessarily have not played a huge role in permission blockchains. Primarily, and you have to keep in mind, the real reason why tokens are required in permissionless is because you have anonymous parties. You need some mechanism. So we don't need.
Yeah, but you could drive adoption through token economics.
Yes.
I mean, you want more Walmarts to come on board, right?
Yes, but I wouldn't say it as token economics as much as keeping track of value exchange, right? Because you don't need to. All I'm saying is technically you don't need to use tokens. You just keep track of how many times somebody's consumed or shared data, or right? So token economics, I usually am very particular with saying that you don't need a native token to make that happen. You can do it in many ways.
A couple of more questions before we go on.
Yeah.
You have one over here?
Yeah, so I was going to ask, when you don't have full adoption for all members in the supply chain, you have some kind of dark spots. Does that cause the entire tracing to break down, where you have maybe a distributor who isn't participating in this system? How do you account for that?
Yeah, typically what happens is, all the parties in a certain supply chain, when they want to solve a certain use case, they talk to each other and say, look, let's all join the system, right? So therefore, it solves itself naturally. In fact, a retailer typically joins the system and they say, oh, okay, already this leafy green supply is connected to Walmart, maybe I can connect with them, right? So typically it's a network effect, right? Because if thousands of folks are on the system, if I join, it's a standard way in which they've connected to the system. They don't have to make many changes other than say, add an additional product, right? And then I get to sort of connect with them. So yeah. Exactly. And that's part of the governance too, right? And remember I said we have a governance mechanism in play, in fact, run by a set of companies to ensure that everybody, so we are really running a community information sharing platform. That's what this is.
I see one more over here. Yeah. Final question. You get the final.
All right. So in the example where you have like spinach or some sort of food spoilage and it causes an illness, it leaves the supply chain and then goes to the consumer, and then potentially if that consumer gets sick, it goes to a hospital or a physician. So do you see anywhere where like some sort of layer of consumer interaction back into that blockchain solves, because now you've got sort of a bottleneck between figuring out what was the cause of that patient getting sick between the doctor and the consumer and back to the supply chain. So like, is there something that's going to connect consumers or doctors back to that supply chain to solve that problem?
This is a great question. So think about it this way, right? When something bad happens with, let's say, spinach or something, the way today it's discovered, the first mile, if you will, is many people get sick, somebody notices it, there's a pattern, and then somehow they figure out, okay, maybe it's spinach bought at this store, right? That's how it happens. That phase is not solved by the system at all, yeah? But then once that happens, you can trace through, find which farm it came from and where all it went to, and do a surgical recall. That this helps with. But so there's time in the first mile and the time in the rest, right? Now, once this sort of system is being used by folks, immediately questions will be asked. Okay, now this is where all the time is getting spent. Is there a way to make things better? I'm absolutely certain that things will happen in that first mile, but today there's no incentive to go there. That's what it is. Right? Great question, by the way. I anticipate there'll be something going on there once this is successful.
Join me in thanking our speaker again.
Yeah.
Before you run, so there was one thing I failed to say when I come in, and maybe it was intentional because Sidney Burris hadn't arrived yet, but there's actually really 4 reasons for Ramesh to be back in town. One is to give this lecture and talk about what he's doing and what IBM is doing in blockchain. fascinating, actually. The second is that tomorrow we're celebrating something called DSP at 50. DS, the Digital Signal Processing, 50 years. There's 50 years since Sidney Burroughs and his colleagues taught the very first DSP course at Rice University. And both of us are sort of, tied to that, and we're part of celebrating that. So there's a lot of people in the room here that's here for that. The other one, he is actually the partnership executive for IBM with Rice is his partner, so we are actually working with him, so we're very proud to have one of our alums spending a lot of time and in the back sort of what you're representing in the partnership, so that's him. And finally, and maybe the most important part of him, and I'm going to embarrass his daughter because I didn't even remember his name, but his daughter is a freshman at Rice, and she's in the back there, so that's probably the main reason.